I am Dr. Rasool, Assistant Professor from Department of Physics, Siddhartha Institute of Science and Technology, Puttur. Today's topic is semiconductors. What are the semiconductors? Semiconductors are the materials which are having electrical conductivity lies between conductors and insulators. Semiconductor materials are classified into two categories: intrinsic semiconductors and extrinsic semiconductors. The extrinsic semiconductors again classified into two types: N-type semiconductors and P-type semiconductors. Coming to the intrinsic semiconductors, the pure semiconductor without impurities is called intrinsic semiconductor. For example, silicon and germanium. In case of silicon crystal, each silicon atom forms covalent bonds with four surrounding silicon atoms. At 0 Kelvin temperature, all the valence electrons are tightly bounded with the silicon atom. Therefore, there is no free electrons within the material at absolute zero. As a result, the semiconductor at 0 Kelvin cannot conduct electricity across the material and act as a perfect insulator. At room temperature, the thermal energy is sufficient to break the covalent bond. When a covalent bond is broken, the bounded electron becomes free by creating a vacancy in the valency band called hole. The higher the temperature, the more covalent bonds are broken. Each broken covalent bond can generate one electron and a hole. In case of intrinsic semiconductors, at any temperature, the number of electrons in the conduction band is equal to number of holes in the valency band. Here, the electron and hole density equal in intrinsic semiconductor. The intrinsic semiconductors are not useful in device manufacture because of low conductivity, and the electrical conductivity mainly depends upon the temperature. If you increase the temperature, the electrical conductivity of the intrinsic semiconductor increases. That's why we go for extrinsic semiconductor to control the electrical conductivity of the material. Extrinsic semiconductors. A semiconductor doped with impurity atoms is called an extrinsic semiconductor. Depending upon the doping, there are two types of extrinsic semiconductors are possible. They are N-type and P-type semiconductors. N-type semiconductors. The N-type semiconductors are produced when a pure semiconductor is doped with a pentavalent impurity such as phosphorus, arsenic, antimony. A phosphorus atom has 5 valency electrons. Out of the 5 valency electrons, only 4 participating in bonding with 4 host silicon atoms, while the 5th electron remains loosely bound. This 5th electron becomes free to move about the crystal and act as a charge carrier. If you observe the band energy level diagram, the energy level of 5th electron is called donor energy level, which is formed near to the conduction band. At absolute temperature, the donor electrons tightly bound to the donor atoms, and the conduction band is empty and the valency band is full. In this case, the N-type semiconductor behaves like an insulating material at 0 Kelvin temperature. At elevated temperatures, the donor electrons exit from the donor energy level to the conduction band, near to the conduction band. Here, in this process, there is no holes created in the valency band. If you further increase of temperature, the electrons exited from the valency band to the conduction band by creating holes in the valency band. Therefore, more number of electrons or free electrons in the conduction band compared to the valency band. Therefore, in the N-type semiconductors, electrons are majority charge carriers and holes are minority charge carriers. Coming to P-type semiconductors, a P-type semiconductor is produced when a pure semiconductor is doped with trivalent impurities such as aluminum, indium, gallium, etc. The aluminum atom has 3 valence electrons. Impurity atom need one more electron to complete its bond with the silicon atom. This electron may be supplied by silicon by creating a hole on the semiconductor. In p-type semiconductors, holes are majority charge carriers and electrons are minority charge carriers, because here if you observe the energy level diagram of p-type semiconductor, the acceptor energy level is formed near to the valency band. At low temperature or at absolute 0 Kelvin temperature, the acceptor energy level is completely vacant and the valency band is completely full. Therefore, it acts as an insulating material at a 0 Kelvin temperature. If we increase the temperature, the electrons excited from the valency band to the acceptor energy level by creating holes in the valency band. And further increase of temperature greater than the band gap energy, the electrons exit from the valency band to the conduction band by leaving holes in the valency band. In this process, more number of holes created in the valency band compared to the conduction band. Therefore, in p-type semiconductors, holes are majority charge carriers compared to the minority charge carriers. Okay.